Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2183, indicates an issue with Engine Coolant Temperature ECT Sensor 2, circuit performance or range. This sensor plays a crucial role in monitoring the coolant temperature in a vehicle's engine. If the engine coolant temperature fails to match expected readings compared to ECT Sensor 1 and Intake Air Temperature IAT Sensor 1, the Powertrain Control Module, PCM, recognizes this inconsistency, triggering the P2183 fault code. Located typically near the engine block, ECT sensors are vital for managing engine performance and emissions. These sensors communicate critical temperature data to the PCM, which adjusts fuel mixtures and ignition timing based on the engine's operating conditions. Diagnosing DTC P2183 is essential, as it can lead to engine inefficiency, increased emissions, and potential engine damage if not addressed properly. DTC P2183 arises when there's a failure in the engine coolant temperature, ECT Sensor 2, prompting the Powertrain Control Module, PCM, to store an error code. The ECT sensors are responsible for providing real-time temperature readings of engine coolant, essential for optimal engine management. Specifically, ECT Sensor 2 is typically located near the engine cooling system and is directly responsible for relaying temperature data to the PCM. When the temperature readings from ECT Sensor 2 are inconsistent with those from ECT Sensor 1 and Intake Air Temperature IAT Sensor 1, the PCM determines that a malfunction has occurred. This inconsistency in sensor data may lead to improper engine tuning, affecting both performance and emissions levels. Addressing this error promptly is crucial to maintaining the engine's efficiency and operational integrity. The potential causes for DTC P2183 include several key factors. A common issue can arise from a faulty engine coolant temperature, ECT, Sensor 2, which may result in incorrect temperature readings. Another probable cause to consider is damaged wiring or poor connections affecting the electrical signals sent between the sensor and the Powertrain Control Module, PCM. Such wiring issues can lead to erratic sensor performance and subsequent code triggers. Additionally, occasional software glitches or programming errors within the PCM can misinterpret sensor data, resulting in an erroneous fault code. It's important to consider all potential causes thoroughly during troubleshooting to ensure an accurate diagnosis and effective repair. Identifying the root cause can help in preventing future issues and ensuring reliable vehicle performance. Upon encountering DTC P2183, several symptoms may manifest in your Honda CR-V. One of the most immediate indicators is engine overheating, as the ECT Sensor 2 may fail to provide accurate temperature data, leading to improper cooling system operation. This overheating can often result in reduced engine performance, as the vehicle struggles to maintain operational efficiency. Additionally, the driver may notice increased fuel consumption, stemming from incorrect fuel-air mixture adjustments made by the PCM based on faulty temperature readings. These symptoms not only signal an underlying issue with the ECT sensor, but can also lead to more severe engine problems if not addressed promptly. It's critical to monitor these symptoms closely, as ignoring them may result in further damage to engine components or a decrease in overall vehicle reliability. The first troubleshooting step for DTC P2183 involves setting the vehicle to the off mode for a minimum duration of 6 hours. This waiting period allows for the vehicle systems, particularly the Powertrain Control Module, PCM, and engine components, to reset and stabilize. After this time, start the engine and allow it to idle for approximately 10 seconds. This step ensures that the PCM can capture the initial environmental conditions and readings from the Engine Coolant Temperature (ECT) sensors. It allows the system to reevaluate the sensor performance and establish a baseline for temperature measurements. Monitoring any new codes or symptoms following this initial startup is crucial, as it may provide insight into the state of the ECT sensors and be indicative of the underlying issue. This reset procedure can help in isolating whether the previous issues stemmed from a temporary fault or a more persistent problem. In the second troubleshooting step, a thorough visual inspection of relevant connectors is necessary. This process specifically involves checking the connectors for the Engine Coolant Temperature (ECT) sensors 1 and 2, ensuring that they are secure and free from damage. Inspect the wiring loom closely, looking for any evidence of fraying, corrosion, or loose terminals, which may compromise the electrical connection. A compromised connection can lead to intermittent signals or data misinterpretation by the Powertrain Control Module, PCM, resulting in triggered fault codes. It's vital to address any findings immediately, as clean and secure connections are critical for accurate sensor performance. A properly functioning connection ensures that the PCM receives the correct input from the ECT sensors, allowing for optimal engine management and performance. The third step involves starting the engine and allowing it to idle for 10 minutes. This duration creates the necessary conditions for the Engine Coolant Temperature (ECT) sensor 1 to stabilize and provide an accurate reading. Utilizing the Honda Diagnostics System (HDS) tool, it's imperative to confirm the readings for ECT sensor 1. The expected normal condition should reflect a value greater than 120 degrees Fahrenheit, 49 degrees Celsius, indicating that the sensor is functioning correctly and effectively monitoring the engine's coolant temperature. If the reading falls below this threshold or shows erratic behavior, this suggests that ECT sensor 1 may be defective or experiencing operational issues, leading to further investigation or replacement. Accurate readings from this sensor are key to ensuring the PCM makes appropriate adjustments for engine management, impacting overall performance and efficiency. During the fourth troubleshooting step, allow the Engine Coolant Temperature (ECT) sensor 1 to cool down to ambient temperature. Be sure to record the ambient temperature accurately, as this benchmark will be essential for comparing the sensor's performance later on. Once cooled, switch the vehicle to the on mode without starting the engine, enabling the Honda Diagnostics System (HDS) to provide a reading for ECT sensor 1. The normal condition mandates that the difference between the HDS reading and the observed ambient temperature should be less than 5.4 degrees Fahrenheit, 3 degrees Celsius. If the margin exceeds this threshold, it indicates that ECT sensor 1 is likely dysfunctional and merits further examination or replacement. This inspection step allows for double-checking the efficacy of the sensor's operation under appropriate conditions, fundamentally impacting engine responsiveness and diagnostic accuracy. The fifth troubleshooting step requires starting the engine again and letting it idle for a duration of 10 minutes. This process facilitates the Engine Coolant Temperature (ECT) sensor 2 to stabilize and produce a reliable reading. As with ECT sensor 1, confirm the values via the Honda Diagnostics System (HDS), focusing specifically on ECT sensor 2. The criterion for normal operation is a reading exceeding 120 degrees Fahrenheit, 49 degrees Celsius, indicating the sensor's capability to accurately monitor coolant temperature as intended. Should the reading be significantly lower or inconsistent, it points towards a fault in ECT sensor 2, suggesting potential replacement or further diagnostics. This step is critical for ensuring that both ECT sensors are functioning properly and that the PCM can make informed decisions based on accurate temperature data in the final troubleshooting step. Permit the Engine Coolant Temperature ECT Sensor 2 to cool down to the ambient temperature once again for an accurate assessment. Carefully record the ambient temperature during this period, similar to previous steps, as it sets the baseline for comparisons. After cooling, switch the vehicle to the on mode without starting the engine, enabling the Honda Diagnostic System, HDS, to read the current data for ECT Sensor 2. The ideal target is that the variance between the HDS reading and the recorded ambient temperature should be less than 5.4 degrees Fahrenheit, 3 degrees Celsius. If this threshold is exceeded, it indicates a malfunction within ECT Sensor 2 and necessitates further investigation or replacement. This intricate examination guarantees that any potential issues with the coolant temperature monitoring system are precisely identified, ensuring the vehicle's operational reliability. After completing the necessary repairs related to DTC P2183, it's crucial to execute a final repair verification. This process includes confirming that the DTC has been cleared from the PCM and that no new codes have appeared following the repairs. Inspect the engine's performance, ensuring smooth operation without any irregular functions. Also, monitor the temperature readings from both engine coolant temperature, ECT, sensors to ensure they stabilize within the expected ranges indicative of proper operation. Regularly taking these readings can confirm the success of the repair and the ongoing reliability of the sensors. It's vital to conclude that the corrective actions taken have resolved the underlying issues effectively. Otherwise, further analysis may be necessary to pinpoint any lingering problems. This step is essential to ensure long-term vehicle reliability and optimal performance. To prevent the recurrence of DTC P2183, implementing a proactive preventive maintenance strategy is essential. Regular inspection of the engine coolant temperature, ECT sensors, should be scheduled to ensure they are functioning correctly. Periodically checking the integrity of the entire cooling system, including hoses and clamps, will prevent leaks or temperature inconsistencies from arising. Furthermore, maintaining electrical connections associated with the ECT sensors is equally important, as frail or corroded terminals can lead to intermittent faults. Consistent attention to these components will greatly enhance the reliability and longevity of the vehicle's engine management system. Proactive measures not only mitigate potential issues, but also contribute to maintaining optimal engine performance and efficiency, ultimately leading to a better driving experience. In conclusion, DTC P2183 signifies a significant concern related to the performance of the engine coolant temperature, ECT Sensor 2. Understanding the importance of both ECT sensors and maintaining their proper function is vital for optimal engine performance and efficiency. Troubleshooting this error meticulously allows for accurate diagnosis and effective repairs, focusing on electrical connections and sensor integrity. Preventive maintenance practices are key in avoiding such issues in the future, ensuring that sensors are regularly checked and cooling systems are properly maintained. Ultimately, remaining vigilant about vehicle diagnostics and performance can lead to a more reliable and efficient vehicle operation, thereby enhancing the overall driving experience. It's important for Honda CR-V owners to incorporate these practices into their regular vehicle care routines. Please like and subscribe to the channel. See you next time.